Here are the notes for 5.7, radical functions. We're going to be looking at different graphs and transformations. Alright, so remember that exponential and logarithmic functions are inverse functions, and quadratic and cubic functions also have inverses. The graphs below show the inverses of the quadratic parent function, which would just be x squared, and the cubic parent function, which would be x cubed. Alright, so we can see here is x squared, and its inverse plus or minus the square root of x. Alright, here is our x cubed. Now since it's an odd exponent, we don't need a plus or minus with it. There is our cubic inverse. Okay, notice that the inverses of x squared is not a function because it fails the vertical line test. However, if we limit the domain, only use positive x values, it will be a function. Okay, if we take a look back at the graph real quick here, so if it fails the vertical line test, what that means, if you draw a vertical line and it hits your graph more than once, then it is not a function. Alright, so if we eliminate this bottom part, then we're okay. It will pass the vertical line test. Okay, a radical function is a function whose rule is a radical expression. So basically we're going to have an equation with a radical, square roots and cube roots mostly. Okay, the square root parent function is f of x equals the square root of x. The cube root parent function is f of x equals the cubed root of x. Okay, for the first one here, graph each function and identify its domain and range. So in order to graph our function, we're going to make a table of values, pick a few points, check the graph in our calculators, and then sketch it on our paper. Okay, so when we fill in the values here in our table, just gave you an extra column here for a little work. Here is our points, and our graph should look like this. When we talk about the domain, remember the domain is the x values. Alright, you may notice in your table, in your calculator, that below 3, you're getting an error in your calculator. Alright, and that's because if we pick a number, let's say 2, to plug into our function, we're going to get the square root of a negative number, which is not real. We can't graph it, therefore not part of our domain. So when we say our domain, we're going to say x is greater than or equal to 3. Okay, remember, you don't have to write this part. You can leave your domain like this. The range, if we look at our graph, has to be y greater than or equal to 0. Okay, there's no negative y values because our square root will never produce a negative number. Okay, so here's the next one. Graph each function and identify its domain and range. So again, you're going to fill in the table, plot your points. Okay, if you need to pause here to get the table filled in, go ahead and do so, and then hit play when you're ready to check your graph. Alright, here are the points that we should have gotten from our table. This is what our graph looks like. Okay, now since it's a cube root, we can get negative answers. So see here we have a couple negatives. They're okay. Alright, so when we look at our domain, everything is okay. So we're going to have all real numbers. Same thing for the y. Y's can be positive, negative, 0. No problems there. So we say all real numbers. Okay, you could use the symbol too if you want. Remember, all real numbers looks like that. When you put this into your calculator, your screen should look like this. Remember, if you want to do the math for, you're going to do type in the 2, and then hit math for, gives you the cubed root, and then you can do the x minus 2 like this. Either way should produce this graph. You can put it in your calculator either way you want. Okay. For this next one, the graph of the cubed root of x, we don't have to put this in our calculator again. This is going to be the same graph that we saw on that first page. Okay, so same thing from the first page. This is what it looks like. Okay, domain and range is the set of all real numbers. If we put it into our calculator, it's going to look like this. And again, if you do math 4, you could also put it in your calculator like that. Okay, next one. We're going to graph and identify the domain, square root of x plus 1. Okay, so go ahead and take a second, plot those points, look at the graph, hit pause if you need to. Alright, this is what our graph should look like. Notice that from the original graph, square root of x, it's shifted to the left 1 unit. Okay, and we can see that in here. Remember our transformation rules. Okay, then check your domain and range. Domain should be greater than or equal to -1, and the range should be y is greater than or equal to 0. Alright, here's a review of all of our transformation rules with examples. Alright, so the examples are for the square root of x. It's going to be very similar if it was the cubed root. Okay, so vertical. Remember, plus or minus, not with the x, up and down. If it is with the x, remember the horizontal is opposite. So minus is to the right, plus is to the left. If it is outside, the number is outside the root, then it's vertical. All right. Bigger than 1 gives you a stretch. Smaller than 1 gives you a compression. Then remember with horizontal, it's the reciprocal. All right. So notice the difference between vertical and horizontal. Vertical, the number is outside. Horizontal, the number is inside. Okay, so this would be a stretch by 5, because that's the reciprocal. This would be a compression by 1/3, okay, because that would be the reciprocal. Alright, our reflection rules are the same as before. If the negative is outside the square root, it's the x-axis. If it's inside with the x, it's across the y-axis. Okay, so let's look at some transformations here. Alright, square root of x plus 5. Alright, and we don't need to graph this in our calculators. If we have the square root of x, what I really want you to do is look at the transformation. So this would be up 5. Okay, so it's our square root of x, but then it would just be 5 units pushed up. Okay, so similarly, if we look at this, think about what the translation for this would be. Okay, and since it's plus 1, it would be 1 unit up. Alright, for our next one, we have 1/2 times the square root of x. So what you need to look at is the 1/2 is outside the square root. Since it's outside the square root, that's a vertical transformation. Since it's less than 1, it's a compression. Okay, so you can see that g is kind of shrunk from f. So it's vertically compressed by a factor of 1/2. Next on our slide, we just have some guidelines for you. It's the same that was in the table. It's just written out as an equation. Okay, but these are all the same rules that we just talked about. Alright, so let's take a look at this g of x and take a second and write down all of the transformations. Pause, and when you're finished, hit play to check your answers. Okay, so we should have a reflection across the x-axis, all right, because of the negative sign. Translated 4 units to the right because of the x minus 4. Okay, so take a look at the next example. Hit pause, and when you are ready to check your answer, hit play. Alright, so first reflected across the y-axis because the negative is inside the square root. And then we have plus 3 outside the square root. That is why it's 3 units up. Okay, and this is what our graph would look like. Alright, next we are given a description. Oh, sorry, we have one more example. Missed that one. Take a second and write the transformations. Again, hit pause and then play when you're ready to check. Alright, so we have 3 transformations here. Vertically stretched by a factor of 3. Then we have reflected across the x-axis from the negative sign. And then we have minus 1 here, which brings us 1 unit down. Okay, now we are given a description and we need to write the function. Okay, so it's kind of like backwards of what we were just doing. Okay, so it's telling us that the square root of x is our parent function. So we know the square root of x is kind of going to be the basis of our equation. Alright, if it's reflected across the x-axis, the negative is going to be outside the square root. Compressed vertically by a factor of 1/5. Alright, vertically is also outside the square root. And translated 5 units down. Alright, down is also outside the square root, so we're going to have the square root of x, and then we're going to have minus 5. Alright, so this would be our answer. Let's take a look at another one. So again, our parent function is the square root of x. That's going to be the basis of our equation. Okay, so let's see. Reflected across the x-axis. Negative goes outside. Stretched vertically by a factor of 2. Okay, vertical stretch goes outside as well. And translated 1 unit up. Okay, so square root of x and then plus 1. Alright, and last we have a little word problem, so take a minute and read this problem, and then hit play again when you're ready to go on. Alright, so they give us this equation. D of a is equal to 0.5 times the square root of a plus 0.2. They tell us that it's going to cost an additional $6 to install the glass. So we're going to put a plus 6 here. So this is going to be our total cost. Okay, D is the total cost. Alright, so let's simplify this. 0.5 square root of a plus, let's see, that's going to be 6.2. Alright, so here's the equation for our total cost. We want to know, estimate the total cost of glass for a picture with an area of 192 inches squared. Alright, so when we write our function notation, what we're saying on the left here is we're finding the total cost when the area is 192. Alright, so the left part here is just a description of what we're finding. Okay, we're not doing anything with these, this D and 192 together. This is just telling us what we're finding. Alright, so what we're finding, to do that, we need to do 192 in here for A, and basically just put that in your calculator. So when we do this in our calculator, we should get 13.13. Very lucky cost. Alright, so the way that we would read this, the total cost when the area is 192 is equal to $13.13.